In 2006 NASA launched the Solar Terrestrial Relations Observatory, or STEREO spacecraft. Over the last 4 years, the two spacecrafts have slowly made their ways throughout the long Earth orbit. STEREO A advancing ahead, and STEREO B falling behind. As they have separated, our view of the Sun has increased. Other satellites near Earth such as SOHO and SOHO continue to watch the Sun from Earth's perspective, while the STEREO spacecrafts continue to see increasingly different views of our Sun. Now STEREO A and B are almost exactly opposite of each other close to the Sun. And for the first time in history, we have a full entire view of the Sun. The Sun has a huge influence on everything in life. Coronal mass ejections and solar flares are the hurricanes of space weather. They have the disruptive power to disrupt navigation systems, communications including cell phone technology, and even electrical power failures. So it is vital that we can predict or foresee when they are coming. These flares can also affect the Earth's weather systems, causing effects in warming the Earth's atmosphere, violent hurricanes, droughts, and even the depletion of the Earth's ozone layer itself. Detecting sunspots and other active regions can also help predict the Sun's behavioral habits. These two spacecrafts will give us a three-dimensional view of our Sun. The Sun rotation is about 27 days. Before the two creates, we could only one view of the Sun from one side. A solar flare would go undetected out of our view. Now that we have both sides of the Sun to view, we can detect a coronal mass ejection much faster, giving us more time to determine their solar flare strength. Our solar system is now drifting into what we call the dark rift of our galaxy. Launched in October 2006, STEREO traces the flow of energy and matter from the Sun to Earth. It also provides unique and revolutionary views of the Sun-Earth system. STEREO has given us the first view of the entire Sun on February 6, 2011, and when coupled with SOHO, will give us complete views of the Sun's entire surface and atmosphere for the next 8 years. Recording these events have been successful to scientists around the world. We are not capable of detecting solar events that were never available to us in the last decades. These two crafts will be the eyes in space, or the eyes to our future here on Earth in relation to our Sun's activity and how it will affect our lives here on Earth. SOLAR Heliospheric Observatory was lucky to be able to record the rare event never seen with the human eye. This event has set an impact with scientists' views on how solar flares can affect the Earth and our atmosphere. October 2, 2011, a bright comet fell into the Sun in sync with a coronal mass ejection CME bursting out on the other side. One of the two chronographs on board the Solar Heliospheric Observatory SOHO caught this view. When a comet comes this close to the Sun, it is almost always destroyed. We see the comet going in, but not going back out. Another event will also affect us again. A comet is one of several to come close to the Earth in the next several months. The next one is going to be on November 8, 2011. It will come close enough to Earth to pass by closer than the Moon's orbit. Of course, it will not hit the Earth. But it does draw concern about the recent solar flares that have recently been occurring in the last 3 months.